NM cable is allowed in Type 5A, 1-wire fire-resistive construction assemblies only if it meets certain conditions. Firstly, it must be installed in accordance with 334.10 through 334.12 FIV. Secondly, it must be enclosed in a chase, shaft, or similar enclosure. Thirdly, the chase, shaft, or enclosure must be sealed to prevent the spread of fire and smoke. Finally, the cable must be supported on a non-combustible base. While the covering on NM cable, non-metallic tubing, and rigid non-metallic tubing may appear to be similar, there are important differences. NM cable has a non-metallic outer jacket that is rated for 600 volts and is resistant to heat and moisture. However, it is not fire resistant and can spread flames if exposed to a fire. Non-metallic tubing and rigid non-metallic tubing have a fire-resistant outer jacket that is made of a special plastic compound. This jacket can withstand high temperatures and prevent the spread of flames. In Type 5 assemblies, the enclosure and sealing measures provide additional protection against the spread of fire and smoke. This allows for the use of non-metallic and rigid non-metallic tubing, as their fire-resistant jackets provide an additional layer of protection beyond the cable itself. While the covering on an NM cable may appear similar to that on non-metallic and rigid non-metallic tubing, the fire-resistant properties of the latter materials make them a more suitable choice for use in Type 5 assemblies. The additional protection provided by the enclosure and sealing measures allows for their use, while the lower fire resistance of NM cable requires it to be used with additional safeguards to mitigate the hazard. In essence, the NEC, or National Electrical Code, allows for specific uses of NM cable in Type 5 construction under very controlled conditions. The key is the added protection of a chase or shaft that is properly sealed to contain fire and smoke. This contrasts with non-metallic tubing and rigid non-metallic tubing, which inherently offer better fire resistance due to their jacket materials. Think of it this way: the code prioritizes safety and uses different methods to achieve the same level of fire protection. When NM cable is used, it demands a robust enclosure. When non-metallic tubing is used, its inherent fire resistance permits its use within the building structure with less restrictive enclosure requirements. The 518 section likely refers to Article 518 of the NEC, which addresses places of assembly. These locations, due to the increased density of occupants, require heightened safety measures. The allowance of non-metallic and rigid non-metallic tubing under these circumstances reflects the necessity for materials that self-extinguish or resist flame spread to a greater degree than standard NM cable. The fundamental difference boils down to material properties. NM cable, while suitable for many residential applications, is not designed to withstand intense heat or direct flame exposure. Its outer jacket is primarily for protection against physical damage and environmental factors like moisture. In contrast, the specialized plastic compounds used in non-metallic tubing are engineered to limit flame propagation, thereby slowing down the spread of fire within a building. The NEC 2005, Section 334.10 through 334.12 FIV outlines the permissible uses and restrictions for NM cable. It is important to consult the specific language of the code to understand the precise requirements for installation, support, and protection. The code is a living document that is updated periodically to reflect advancements in technology and improvements in safety practices. Therefore, always refer to the latest edition of the NEC for the most current regulations. Furthermore, local jurisdictions may have additional amendments or interpretations of the NEC that must be followed. It is crucial to consult with local electrical inspectors or authorities having jurisdiction or odds to ensure compliance with all applicable codes and standards. The 1-hour fire-resistive construction rating of Type 5 of buildings indicates that the structural elements of the building, such as walls, floors, and roofs, are designed to withstand fire exposure for a minimum of 1 hour. This rating is based on standardized fire tests that simulate real-world fire conditions. The use of fire-resistant materials and construction techniques helps to compartmentalize a fire and prevent it from spreading rapidly throughout the building. Electrical systems are an integral part of a building's overall fire protection strategy. Properly installed and maintained electrical systems can reduce the risk of electrical fires and minimize the potential for fire spread. The NEC provides detailed requirements for the selection, installation, and protection of electrical wiring and equipment in various types of buildings and occupancies. The requirements for places of assembly, as outlined in Article 518, are more stringent than those for residential occupancies due to the higher risk associated with large gatherings of people. These requirements address issues such as emergency lighting, exit signage, and fire alarm systems, as well as the types of wiring methods permitted. The use of nonmetallic and rigid nonmetallic tubing in places of assembly is intended to enhance the overall fire safety of the building and protect occupants in the event of a fire. The fire-resistant properties of these materials help to contain the fire and prevent it from spreading to other areas of the building, providing valuable time for evacuation. In summary, the NEC allowance of nonmetallic and rigid nonmetallic tubing in Type 5 assemblies, particularly in places of assembly, reflects a careful consideration of fire safety principles. The code recognizes the importance of using materials that can withstand fire exposure and limit flame spread, and it provides specific requirements for the installation and protection of electrical wiring and equipment to ensure the safety of building occupants. Always consult the latest edition of the NEC and local codes, and work with qualified electrical professionals to ensure compliance with all applicable regulations. This explanation is focused on the fire-resistant properties and application of NM cable versus nonmetallic conduits in Type 5 construction, particularly within assembly occupancies. The distinction arises from the inherent differences in material composition and their respective abilities to withstand and retard the spread of fire. The NEC guidelines are structured to provide a layered approach to safety, where the selection of wiring methods and the implementation of protective measures are tailored to the specific characteristics of the building and its occupancy. For NM cable, which lacks the inherent fire resistance of nonmetallic conduits, the code mandates additional safeguards such as encasement within sealed chases or shafts to mitigate the risk of fire propagation. This approach acknowledges the widespread use of NM cable in building construction while ensuring that its application does not compromise overall fire safety. Nonmetallic conduits, on the other hand, benefit from their fire-resistant properties, allowing for a more flexible range of applications, especially in occupancies where the potential for fire hazards is elevated. The code specifications for places of assembly, as detailed in Article 518, underscore the importance of using materials that can contribute to life safety in the event of a fire. The allowance of nonmetallic and rigid nonmetallic tubing in these settings reflects a judgment that their fire-resistant qualities provide an added layer of protection for building occupants. It is important to recognize that the NEC is not a static document, but rather a continually evolving set of standards that are updated to reflect new technologies, evolving safety concerns, and insights gained from fire investigations and research. Consequently, it is essential to consult the most recent edition of the NEC and any applicable local codes when designing and installing electrical systems. Moreover, the interpretation and enforcement of the NEC are ultimately the responsibility of the authority having jurisdiction. Therefore, it is always advisable to consult with local electrical inspectors or other qualified professionals to ensure that installations comply with all applicable requirements. Understanding the rationale behind the NEC regulations is crucial for electrical contractors, engineers, and inspectors. It enables them to make informed decisions about the selection of wiring methods and the implementation of protective measures, ultimately contributing to the safety of buildings and their occupants. By focusing on the fire-resistant characteristics of different wiring materials and the importance of proper installation techniques, this explanation aims to provide a clear and concise overview of a complex topic within the realm of electrical safety. Remember that the information provided here is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with qualified professionals and refer to the latest edition of the NEC and local codes for specific guidance on electrical installations. Furthermore, continuing education and training are essential for staying up to date on the latest developments in electrical safety and the NEC. By investing in professional development, electrical professionals can enhance their knowledge and skills, ensuring that they are equipped to provide safe and reliable electrical services. The NEC addresses specific requirements for electrical installations in various types of occupancies, including residential, commercial, and industrial buildings. These requirements are tailored to the unique characteristics and potential hazards associated with each type of occupancy. For example, the NEC includes specific provisions for electrical installations in healthcare facilities, data centers, and hazardous locations. These provisions address issues such as emergency power systems, grounding and bonding, and the use of explosion-proof equipment. The NEC also addresses the installation of renewable energy systems, such as solar photovoltaic, or PV systems and wind turbines. These systems present unique challenges for electrical safety, and the NEC provides specific requirements for their design, installation, and maintenance. The NEC is a comprehensive document that covers a wide range of electrical safety topics. It is essential for electrical professionals to have a thorough understanding of the NEC in order to ensure the safety of electrical installations. The NEC is not intended to be a design manual, but rather a set of minimum safety requirements. Electrical engineers and designers must use their professional judgment and expertise to design electrical systems that meet the specific needs of a building and its occupants. The NEC is updated every 3 years, and it is important for electrical professionals to stay up to date on the latest changes to the code. The NEC is available for purchase from the National Fire Protection Association, or NFPA, and other organizations. The NEC is also available online through various subscription services. The NEC is an essential resource for electrical professionals, and it is important to use it correctly. The NEC should be used in conjunction with other applicable codes and standards such as the National Electrical Safety Code, or NESC, and the International Building Code, or IEC. The NEC should also be used in conjunction with manufacturers' instructions for electrical equipment and materials. The NEC is a complex document, and it is important to seek professional guidance when interpreting and applying it. Electrical inspectors, engineers, and contractors can provide valuable assistance in ensuring that electrical installations comply with the NEC and other applicable codes and standards. In addition to the NEC, there are many other resources available to help electrical professionals stay informed about electrical safety. These resources include trade publications, industry associations, and continuing education courses. By staying informed about the latest developments in electrical safety, electrical professionals can help to prevent electrical fires and injuries. Electrical safety is a shared responsibility, and it is important for everyone to do their part to ensure the safety of electrical installations. Building owners, managers, and occupants should be aware of the potential hazards associated with electricity and take steps to minimize the risk of electrical accidents. Electrical safety tips for building owners, managers, and occupants include inspecting electrical cords and appliances regularly, avoiding overloading electrical circuits, and never using water near electrical equipment. The electrical safety tips also include keeping electrical panels and equipment clear of obstructions and ensuring that smoke detectors and carbon monoxide detectors are properly installed and maintained. By following these electrical safety tips, building owners, managers, and occupants can help to create a safe environment for themselves and others. Electrical safety is a critical aspect of building design, construction, and operation. By understanding the principles of electrical safety and following the requirements of the NEC, electrical professionals can help to ensure the safety of electrical installations and prevent electrical fires and injuries.